Okay, we have a couple things to do today. Okay, real quick, housekeeping stuff. Book check-in is Monday. Remember that? I moved that date. I had it set for Friday. I'm not here Friday. You'll have a sub. Just remember on Friday, bring headphones just in case the technology doesn't work. I'll already have the video posted to the website. You can just go and watch it yourself. If you have headphones, then you're not distracting the 20 other people in the room, kind of watching at the same time. The reason why I'm doing that is because I said today, starting today, we're going to be looking at the semester test, and we're going to look at the questions, and we're going to start looking at, reviewing about, I think there's 15 questions on yours, I think I came out to be, I'll have to look again. That means we're going to be doing, maybe it's 13, I'll have to look, but we're basically doing 3 or 4 each day. That's basically what we're doing, starting today, going tomorrow, going Friday, going Monday, and then our semester test is next Tuesday. Make sense? So we're going to start that today. Practice guides. I'm going to hand these out for you. These are yours to keep until Tuesday, then you have to turn them in. Did everyone hear that?
Yeah.
They are due Tuesday. Okay, completed. Don't walk in here Tuesday and like, oh Lord, I didn't finish it. We're doing it for the next 4 days. You have no excuse.
I broke my kids' letter. Sorry.
Alright, put your names on them, all the good stuff. You guys know the drill. We'll get started on that today, I think. Look at my front job. I think it was 13.
The left side.
12, alright, so we're doing about 3 days.
It's more of a fraction.
So we got 12 rounds, so we're doing 3 a day.
Did you draw that?
No vocab, this is the letter
No
C.
way.
Yes?
Is this over the whole year?
No, just a semester.
Okay.
Okay.
It's the name semester test.
Well, in Spanish, it's over the whole year, so I gotta ask now in every class.
Alright, hey, we're good? Everyone's got one?
Book I'm doing it on. Really?
Okay. Now, this guy, we're going to go through 3 today. So the goal today is go through the first 3. They're actually really simple. We're going to do that the last 15, 20 minutes of class today. Okay, so the last 15, 20 minutes. But up until then, we're going to look at, we're going to look at doing a couple constructions. We have to finish up the 2 that we didn't look at yesterday. And then I want to look at 1 today that hopefully we can get to. Okay, so those practice kits, just put them off to the side. We'll come back to it here in about 15 minutes. I only have a couple constructions I want to work on today. I think, we did construction number 4 yesterday, correct?
Yeah.
The new perpendicular one? Okay, what? What was that? Yes, I'll hand back the other ones because we're going to keep adding to it. So let me give those old ones to you. Alright, put them.
A week and 2 days.
Okay, so I'm going to hand them back the old ones. Again, we're going to staple the new ones onto this today. So this will probably have about 2 staples in it by then today, and hopefully you know what to do.
Like 9, 10 days in the future.
Yeah, so on your new sheet of paper, good question. On your new sheet of paper, you need to put your name and put a 3 underneath it. This is the 3rd day of constructions. This will be your 3rd score this week. And I'll be putting those in probably tonight actually for you guys.
I don't know.
Okay, let's see, Abby,
Nice.
Jay, Matt,
Algebra 2.
Mitch, and Luke. Okay, I think everyone got them back. Okay, all right. So this will be your 3rd one. So on your new blank page, put your name on it. We're gonna do constructions. We'll look at one more time at number 4. We're gonna do 5 and 6 and add number 7 today, if we get a chance. My goal is to go about 15 minutes in, and then we'll get to the new ones today. So let me hand out your tools that you're gonna need.
Wait, so we don't have to write anything for the first 15 minutes?
Okay, double check right when you get them. Make sure you have lead that is working.
It's only Wednesday.
Wait, so we're
I
just
don't
doing
want
a
to
new
that's what Spanish teacher.
Because if we are, I just don't want school.
I don't want school.
But I'm not changing my
What
future.
thing?
No,
it's not. Wait, it's Friday?
No, it's next whatever.
Okay, double check your lead. Make sure everything's working.
Yeah, it's not. I'll fix those.
Heck,
It's
no.
a protractor, you
But
know.
they're all on different days.
All right, then I'll send your board.
I need a new piece of wood.
Okay.
I'll fix it
All right.
on my own.
But no,
All right, so hey, we gotta get going through this pretty quick. Yesterday, we did number 4, the 4th construction. I wanna review that, so if you go and look at your second page. Yesterday, we should have done a brand new construction. This was construction number 4. I wanna talk about that today. Okay, this is the one where, okay, you're given a line segment, and you could pick any point on it. So I think we called these A and B yesterday. You can pick any point on A, B, and I think we called it like point P, called this. And we could draw a perfect perpendicular line at point P. That's what we did yesterday. Now, how we did this, number 1, you were supposed to take your straight edge, extend this wall straight, whatever side it was on. So if I was on the left side, you extend that wall. If point P was over here on the right, you extend that wall. If it's in the middle, I extend both just to be safe. Then what you're supposed to do is take your compass. Take your compass. You were supposed to open up random size, doesn't matter. We put the pipe on letter P. We made a mark on both sides of point P. So it was something like this. So here's point P. We made a mark on both sides of it, like that. And from these 2 points, I think we called them M and N yesterday.
Yep.
That was M, this was N, N. From there, we could draw the perpendicular. Because basically what we did is we made this in such a way that point P was the perfect center of N to N. It's like the perfect middle of it. So how you actually made the perpendicular, you had to open up your compass where you put the little pike on one of the points you just made, so I put on M. You open up the compass so it's past the letter P, and you can make the marks above P and below P. And then we switch around, we go from letter N, and you do the same thing. Go from above and below, and where X marks the spot, you're able to draw a line that connects the 2 X's. And what should happen if you do this correctly, if we do this correctly, the line should be perpendicular and it should go right through point P. Now why that was helpful is because yesterday when we were doing that whole square idea, the problem was everyone was having struggles, like the most part from every class, they could not copy angles. It was too difficult for anyone to do. They couldn't figure out how to take a 90-degree angle and copy it. So the trick was, if you picked your line segment and you pick this as point P, you could make a perpendicular right there using that construction. You could extend this wall further, make the 2 marks on either side, make the X's above and below it, and then you could draw the line, and that makes the perfect L shape right at the corner where you wanted it. That's why this one is helpful. Questions, comments?
You can do that with the other points.
You could do that with all the other points. So then you can do it over here as well. Then you can measure how long the walls need to be to make it perfectly square and then draw the line straight across. So it does make it easier. But the problem was, doing the first 3 constructions are not difficult. It's just you have to put them all together to make that perfect square. Okay, let's go to construction number 5, new one today. Construction number 5, so we'll take our time going through this one. Here's what you need to do first. You should be on the new paper now, right? Hopefully you've already had your name on it. You put number 3 on the top of the page somewhere. On number 5, you need to take your straight edge and draw a line segment. You need some room above it and below it. So don't draw it too close to like the bottom of your paper. It's a new piece of paper, so you should be putting it somewhere near the top anyway. But you need a line segment of any particular length you want. It doesn't matter the line, okay? We'll call this one, we'll stick with the A and B route. I think we're pretty much used to that. Yes. Okay. I might just switch you out. It's too inconvenient for right now. I'm trying for that. So here you go. Switch out. Yeah, probably go on the inside of it. Okay. Is everyone good? Everyone's got their line segment? Okay, above the line segment, you get to pick a point that is not on AB. So what I'm going to do is I'm going to go above this line, and I'm going to pick a point anywhere I want. This looks as good as any. It doesn't have to be above the middle, it's just above the line. Technically you could do this one below, but I think if everyone does it above, it makes it a little bit easier to understand it. So you're going to pick any point above it. What we're going to try to do here on construction number 5 is to draw a perfect perpendicular line, like a 90-degree angle, from this point down to this line that it isn't attached to. So again, like if we're going into architecture, right? The last one was perfect for if an architect had a blueprint and they were trying to draw, like, I think I used the example, like they're trying to put a closet in a room, where you try to make the perpendicular from a wall that you already have. Well, this one's good. What this construction is, if you have the blueprint and you have a wall, and you want to make another wall that goes perpendicular straight down to it. So you pick a point on the wall and you're going to make it, maybe you're going to close off the kitchen or a bedroom. So you want to make a perfect 90-degree wall there. This is the setup for how you do it. All right, so first step, take your compass now. Does everyone have the drawing up?
Yeah.
Okay. If your line, or I should say, if your point is really close to the left side, I'm betting on most people put it in the middle. But if your point is really close to the left side, you need to extend that wall straight like we did yesterday. If this point is really close to the right side, extend that wall straight out. If it's above the middle, you should be fine, but you might need to extend both sides. Mine's kind of close to the left side, so I'm just going to take my straight edge and extend this. But we're going to use the compass here in a second. I don't know if you'll need this. This is really more of a safety precaution, just in case you picked your point really far away from your line. If it's really close to the line, you probably don't need to do this. So. We're good? Take your compass, open it up to a random size. Now this random size isn't quite random. It's going to be at a point where you can put the little pikey end on that floating point that you just made a little bit ago. And what we're going to do is we're going to draw a smiley face on your paper. And what I want to happen is I want the smiley face to be able to hit this line that you just made twice. It doesn't have to hit at A or B or anything like that, or anything special. It's pretty random how I'm going to open mine. But I need to draw a smiley face so it actually hits the wall twice. And again, you're putting the pike right on letter P. So this looks as good as any.
Yes.
There. Now, when you do that, do not change your compass again. You have to leave the compass the same after you make it. It should hit the wall twice. If it didn't, you need to make it a little bit longer. Okay, it should look like this. And again, don't change the compass once you've done this. In fact, what I want you to do with your pencil, your normal pencil, I want you to circle where the smile actually hit your line. So draw the little circles where the smile actually intersected line AB. Those are, I call them the corners of the smile, like the corners of your mouth. All right, is everyone good? Everyone's got it? Okay, what you're gonna do, take your compass now. Take your compass. Put the compass so the pikey end is on one of the corners of your mouth, and hopefully you did not change the compass. You kept it the same from when you do that original smile. Put the pike on one of the corners, and you're going to draw a line. And how do I know this arc that's going below down here? It has to be below where point P is. So it's got to be below your point. It's got to be straight down. Okay, so you're going to draw a line down there. Once you have that little arc mark drawn, you're going to go over to the other corner of your smile and do the same thing. Again, notice, I'm ignoring A and B. A and B could disappear for all I care, and it would not make the difference on this one. I just put it in there because we had to have the original line. Again, I'm making the mark down below, not above. It's got to be below point P, and it should have made X marks the spot. We're good?
Yes.
Okay, the last step here is draw the line that connects P right to the X.
I did it.
Draw a line that connects P straight down to the X.
That's all I heard.
Okay, that's what it should look like. Okay, what you've learned now is 3 different types of perpendiculars. One where you can make it that goes through the middle of a wall, one where you can pick any point on the wall, and a perpendicular from a point that's not on the wall. So, question?
Maybe in a square, could you put a point right above A?
Yeah, technically you could. If you kind of knew like directly where above was, yeah, you could put one up there and draw a perpendicular line. So, and that's one way. I've seen somebody do like the square where they did that line originally, and then they used that wall as the wall for the rest of the square. So it was kind of clever how they did it. Okay, questions?
haven't done yet. That isn't even
Oh,
school
look, me
yet.
too.
What?
Mine isn't even.
Yeah, so on the semester test,
I got 2 of them.
hey, shh, on the semester test, right now, you're kind of looking at it, you're like, okay, there's 12 questions. Technically, there is 2 more that I haven't added to the back. They go back here. Because guess what we put on the back?
These?
Constructions. I picked 2 of them
Heck
at
no.
random. So you have to kind of know your
Will you
things.
tell me which ones they are?
Nope, but here's the good news. Since you guys are making all your notes on this paper, you get to use that paper
Oh, good.
to
On
help
the
you out
test?
on the test.
Test?
So, so anything you write on this will help you out for the constructions, but you're not allowed to write random stuff like, oh, theorem 10, 14 now.
Why not?
You can only use have the constructions on. All right, we're good so far? Last one of the day, construction number 6. Construction number 6.
Don't let Jade see.
Okay, and then tomorrow we'll do a couple more constructions, but today we have construction number 6. Last one today. Okay, here's what we're gonna do. We're gonna draw the perfect
Smash my fingers.
Circle.
60-degree angle.
I want to.
5, 6.
60 is one of those special angles we use in pre-calc a lot,
Oh.
and calculus. It's kind of a nice number for
I
triangle.
went on point B again, but you know.
All right, the perfect 60-degree angle. I know that's weird. A lot of people don't think of 60 degrees as a perfect angle. It is really helpful for pre-calc and calc. We use it quite a bit. So, here's what you need.
Yeah, it's a third.
Take your straight edge and draw a segment on your paper. This is the easiest construction we have up to this point. Maybe not as easy as one, but all right. Now, when you draw your segment, it can be of any length. Don't draw it like too big, but you do need room above it. So wherever you put it. Now, if you don't have room above it, just turn your paper over and just imagine you're going, above it. So, all right. This line segment, let's call it C and D. Okay, the longer the line, the more difficult this one will be, the shorter, it's kind of easier.
Okay, good.
Alright, now, take your compass. You need to measure how long CD actually is. So measure how long CD is with your compass. When you do that, and again, I'm putting a little pipe on letter C, the pencil letter D.
Wow, mine's a squeaky one.
Now, once you have this marked and you have that distance measured, all I want you to do is don't pick up your compass, just swipe up and make an arc that goes all
Oh
the way up.
gosh, she's a little too big.
Well, number 5 was it just a
Perpendicular from a point.
Okay.
Yeah.
Perfect, from a point.
Oh, it wasn't 90.
Okay? We're good so far?
Perpendicular is.
Well, we're intersecting my words.
Okay, now, yeah, I know mine went through my words too. Okay, once you have that arc drawn, again, all I did was measure how long CD was and draw the arc straight up. Once you have that, just switch your compass around and go from the other letter. So I'm gonna go from D now
Oh, heck no.
You're right.
and loop my way up.
Wait, Mr. Wood, what?
I don't want to
Ooh, that one's down a little bit.
See, I lied to
Okay.
you.
How are the marker board is?
Oh, we have to go all the way up?
You have to go up, because they're gonna meet somewhere up top.
Yeah, so do you have to just like?
Alright, yeah, it's pretty much marked the top, but this is just kind of makes it easier. Alright, does everyone have them drawn?
No, I don't. Just a second. I'm not ready. My goodness sucks, I need a new one.
Don't worry, boys. I found it.
I love you.
It's like a 15.
Alright,
Wait!
I'm going anywhere. Just making sure. Make sure everyone's got their lines and arcs.
Go anywhere.
Alright,
Town.
okay. It looks like everyone has it. Draw the line from letter C. Draw the line from letter C out to X marks the spot. Just draw the straight line out.
Can we do a 36-degree angle now?
30?
36.
I can show you eventually how to do one, yeah.
No, no, no.
I know it's a little weird, but there is a way to do it.
I don't even
So, alright.
He's really good at that.
Boom.
Now, when you draw that out, this angle is 60 degrees.
How?
Basically what we just made is you made a perfect
No way.
equilateral triangle.
Okay.
So if you were to draw the other line, the other wall would be the exact same size, because that's what we did. We basically measured how big this was and drew a triangle. So this triangle is equilateral, and equilaterals have 60-degree angles.
So you
That's
can make
basically what we did.
30 degree angles off of that if you set a perpendicular
So we can do the perpendicular, you can, the ones we do tomorrow, like angle bisectors tomorrow, that'll help us. We'll do parallel lines tomorrow, we'll do some other stuff.
Yeah,
Okay.
that's right.
Just like 5 minutes.
Okay, hey, are we good? The perpendicular would actually work.
Math is so fun.
Okay, we're good? Okay, put your tools back in the bag. I'm gonna collect them here in a second. Page number 3, we're gonna staple it to your other one. Hopefully you have your name and a number 3 on it.
I do not.
But we are gonna go through your practice semester test. So, I'll walk around the room, I'll have the stapler.
Number 2 is.
What?
What? I don't even know.
Alright,
Hey, no,
Where's
do
X?
that.
alright, so on this particular problem, this is a parallelogram. One of the first properties we learned in chapter 5, because that was one of the chapters we had in this particular semester, that on a parallelogram, the opposite walls are equal, the opposite angles are equal. So, like for instance, what is A equal to on this picture? 5, right? Because the opposite wall has to be the same. So, off to the side, you have to write what each of these letters are. There's A, B, X, and Y. Okay, so A has to be 5.
What's A means?
X is 120.
X is 120, yep, because the opposite angles are equal. And you guys get the idea. Now, there's always one letter in particular that's always challenging. The one letter on this particular problem is the letter Y.
52.
There's no number across from the letter Y down here.
I know how to do
The
it.
trick is that you can transfer the 38 inside this triangle down here. That's called an alternate interior. And then once you have the 38 in there, then you know that you can add up these to make 180. So because you have the 120, you have the 38, and then the Y is left over.
Wait,
So just take 180 and subtract the other 2 out.
I can't even.
22.
So,
We do some math here.
so angles can hop in there because of alternate interiors. So they can hopscotch diagonally in. So I don't know how you want to think of it. Maybe you want to have the 120 up here, and you want to hop the Y over here. Maybe that's a different way to do it. But either way, you're going to have a triangle where you have to find the one missing angle. Remember, triangles have to be 180.
I see.
B is the same thing, and that's opposite wall. That should be easy. Okay, the first problem should be easy. Now, the only thing I'm worried about is that the only other type of problem that we've had with parallelograms is where they had diagonals.
22.
They had diagonals, and the diagonals are equal. What I mean by that is that like this piece here has to equal this piece has to equal that one. So whatever they are. So if this is a an x plus 4 and this is a 20, you could set these things equal to each other because the diagonals bisect each other on a parallelogram. So x plus 4 equals 20, and you can solve that out. X is 16. Okay, because you can set them literally equal to each other. Okay, does that make sense what you can do there? Yeah. Okay, are we good so far? Okay, I'm moving on to the next one. I think you guys can figure out that first problem by yourself now. Or we pretty much figured it out. I think you have to solve for y star. Alright, the next one. What are we on? Number 2. This one is a system. It is guaranteed to be a system on your test. Okay, we did systems right away. It was the very first few problems we had this semester where you had to find where intersection points were of lines. Okay, so on this particular problem, I'm going to walk you through it. You set the opposite walls equal. It's still a parallelogram, right? So the 2x plus 5y is equal to the 30 on the bottom. The opposite walls are equal. And then the diagonals are equul. The only number that isn't used in this problem is that stupid 20. They're trying to mess with you. So the 2x plus 2y equals the 18. If your numbers get really faded, sorry, that's an 18. This is a 2x plus 2y. Okay, so again, I set those equal. Now, this is what a system is. You stack them on top of each other. You have two different equations stacked. They both have two variables. That's how you know it's a system. If they don't have two variables, you don't have to do this. You just solve for each letter by themselves. But if it's two variable like mine are, you have to stack them and then pick one of the letters and make them the same numbers. Just pick the x's. They're already the same number. If they're not the same number, you can multiply rows by different numbers to make them the same. Maybe you need to make both 6s, or maybe you'll make these both 4s. I don't know. Multiply the rows by different numbers to make them. Okay, so I'm going to make them both 2s. So they're already 2s, but I need to make them opposites. So I'll make maybe the bottom row negative. So make the whole bottom row negative. So when you do that, now you can add these straight down. So 2 plus -2 is 0, the x's are gone. 5 minus 2 is 3y. And 30 minus 18, what is that, 12? And then you can solve for y has to be a 4, because you can divide by 3. So now that you know one of the letters, you can go plug it back in and go find the other one. So now which equation do you want to plug it into, top or bottom? Top, okay, so top. So we're going to plug that 4 back in, and it has to go into the y letter, because y is 4. So 2x, Jesus, marker's down. 2x plus 5 times y equals 30. I'm going to plug the 4 in, and the 4 has to go into the y location. So if you're seeing how I'm doing that, this turns out to be 20. I'm going to subtract the 20 across, making 10. And then you can divide by 2. So your x is a 5. It is guaranteed to be a system on your test. Guaranteed. Now the only other type of problem, bless you, the only other type of problems that we've had with these, we had triangles where we had systems. We had, I think there was a potential problem for a system when we did the trapezoids, where they had a mid-segment line in the middle. There was potential for that. The ones I'm worried about is like if you had a triangle like this, and they had what they call the mid-segment line. We talked about this with trapezoids. This mid-segment line is related to the bottom. Okay, on a triangle, this line is exactly half the bottom. So if the bottom's 10, this line's 5. If these are midpoints, because that's what a mid-segment is, these sticks are equal to each other. These sticks are equal to each other. Like we've talked about that back in triangles when we talked about mid-segments. We applied them also to trapezoids. I think with trapezoids, when we did a problem like that, we had a trapezoid like this, and you had the mid-segment line, and what we talked about with this one is that the top and bottom, the number here is the number directly in between them, whatever that is. Okay, if that was 10 and this is 12, this number is 11, it's the number in between. Well, there was a way that you could do systems with these, because they could do this, x plus y, and this is a 15. Well, those should be equal to each other. You could set those equal because that's a mid-segment. If this is 5 and this is a 2x plus y, fine. This thing here has to equal 10. Because you know it's double whatever that bottom one is. We talked about those a long time ago when we were with triangles. So I'm just trying to warn you of like the shape that I can put here. I don't have to put a parallelogram. I can put any shape I want. But it's going to be a system, it's guaranteed. So you're going to have to do it some way like I just showed you. Okay, last problem on this first page, number 3. It's going to be something to do with parallel lines. It could be with triangles, it could be with the quads. On this particular problem here, number 3 in yours, this problem I believe, I wonder if I have the wrong one.
Yeah.
I had a couple different versions of your practice test. Let me pull it up. I've had a bunch of different ones over the years. I kind of switch them up every now and then. Let's see, is this yours? All right, first problem is the same, second problem is the same.
Yeah.
Okay, good, so I have different versions. All right, so on this particular problem, we have a bunch of parallel lines, okay? These are equally spaced, okay? So the idea is that if these are all equal spacing, then the idea is that whatever this is, so they tell me AB is a 5x and BC is a 2x plus 12, then these two things are equal to each other. Because what do you know about parallel lines?
They're equal.
They're equally spaced. They'll never touch, right? So you can just set the 5x equals to the 2x plus 12. And then just solve. Like it's a super easy problem. We talked about a lot of parallel lines this semester. That was just an easy thing to do. You solve for x, you plug it into a little blank. It should take you like 3 seconds to figure that number out. But the types of problems I'm worried about is like, I could put another system there, I could put a quad, I could put a rectangle there. Because I could put any shape I want that has parallel lines in it. I could put the trapezoid with the mid-segment line, I could put the triangle with the mid-segment line. There's just a lot of things that had parallel lines in it, and you just have to figure out how to solve it. So I kind of made an easy one here. All right, questions on the first 3. Okay, hopefully you figure those out. Keep your practice guide. Your constructions, I want these. I want to hold on to them because we're going to add more tomorrow. So I'm gonna walk around, make sure your name's on them. Make sure you staple them together if you haven't already. I'm gonna sign you out. Make sure you have your sheets. Perfect.